Hi guys, this is the 10A part 2 notes, and we're doing example number 3. Once again, same kind of problem as we did in example number 1 and 2. Set up each trig ratio below by identifying sine, cosine, and tangent of angle theta. So guys, remember in trig, our trig identities, our trig ratios are always with respect to a specific angle. And the way that we make sure that happens is that we actually mark the sides. We identify those sides. And the first thing that we always do, we're going to find that angle that is theta. Okay, so there's our angle. Now we need to identify the different sides, and we're always going to start that by identifying that long side opposite our 90-degree angle. That's our hypotenuse, okay? Opposite that 90-degree, that long diagonal, that's the hypotenuse. The angle that, or the side that is actually touching theta, we call that the adjacent side. We label that with a capital A. I'm going to try to make my labeling a little cleaner this time. That side that is opposite of theta all the way across, we're going to label that with an O. Well, let's take a look at this triangle and say, what is different about this triangle compared to examples 1 and 2? Well, the difference is I have a value for my opposite side and my hypotenuse, but I don't have a value for the adjacent side. So how am I going to find the value or the length of that adjacent side in order to complete my trig identities? Well, that's where 10A part 1 comes in handy, because we know how to find a missing side. We know that the Pythagorean Theorem gives us a formula, a squared plus b squared equals c squared. Another way to put that is to say, well, the leg squared plus the leg squared, doesn't matter which one, equals the hypotenuse squared. This is just another way of remembering that formula that comes from the Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared. And we can just work that really quick and find out what that missing side is so that we can go ahead and fill in those trig identities. So one of our legs, we can see we've labeled them to do a trig problem, but we know that these two you can think of them as that right angle sides, the two sides that come to a nice 90-degree angle. Those are our legs. So when we fill in this formula, we'll just write it 15 squared, that's one of our legs, plus, our other legs are x squared, and then our hypotenuse is 17 squared. All right. Now again, when we are doing these kinds of problems, we're just going to take our side there and square it. That gives us 225. We still are plus x squared. What's 17 squared? Well, 17 squared is 289. And now to finish this out, we're going to subtract 225 from both sides. And even though this is in the beginning of our term here, it's positive and we know it's being added to x squared. So this sometimes throws students off, but if you know that this is not multiplying the x squared, and you know that this is positive, then we know to subtract. Okay, so that will cancel and we'll get x squared equals 289 minus 225, which is 64. To solve for the length of that side, though, we need x, not x squared. So we need to take the square root of both sides. Square root of x squared is just going to give us x. Square root of 64, guys, when you do these, you always want to start with your calculator and just ask, is it an even or perfect square? It is, and so we're going to use that number. And we'll just fill it in for that missing side. And that way, now we've got all the missing sides. Instead of x here, we're going to put that number in 8. And when we fill in our trig ratios, now we have numbers to fill in for all of our sides. Okay, so if you're missing a side, just find that missing side using what we learned about the Pythagorean Theorem formula in 10A Part 1. Okay, there's lots of videos showing how to do that if you missed that. So sine of theta, we know, is opposite over hypotenuse. Now our opposite, we know that that is 15. Our hypotenuse is 17. The cosine of theta we know is adjacent over hypotenuse. So here's that 8. Hypotenuse is 17. Okay. For tan of theta, it's opposite over adjacent. So opposite is 15. Adjacent is 8. And guys, feel free to leave them in their fraction form. Okay? Thanks so much for watching.